Yeah, thank you very much. Let me start from maybe introduction. So now I work as a research manager in Nvidia, and would like to talk about our recent work. So basically, let me start from motivation, why we did this kind of work. Maybe you are familiar with a big open corpus, which called Common Crawl corpus, and it is largely used for language modeling, and it's kind of whole internet scrapped and parsed already, and it is nice to use it for research, and you can even select your language, I don't know, Armenian part, Russian part, and model this is somehow. But you can notice that sometimes there are a lot of links to audio, and actually we can also use it to model and handle it somehow. So our community is research community, and we usually don't really like this kind of work with data. It's time consuming and in some sense boring, but it's very important because the result is very dependent on quality of data, right? And this kind of big companies happy to help with this work. So that is why we create design open source implementation of multilingual speech data set preparation pipeline, meaning open source code, right? And release some audio data set consisting of source of links. Why source of links? Because there is, so it is open internet, and we are not sure about license of this data. So this is how we cannot take it and keep it. So we just make a subset of this data set as a links and processing pipeline. So you can take a links, follow this pipeline, and receive a data set. So this is how it works. And then we provide some evidence of usefulness of this workflow and even data sets. So we try to train some models using this data. So it is multilingual data, so we can train single lingual, we can train multilingual models, and if it's we can improve our metrics, so it is fine. So this is kind of motivation. How we did it? So to do it kind of useful for people to reuse, so we create some simple framework with pipeline, like data processing pipeline. So what is data processing? Data processing, it is basically, some list of algorithms, and because you need to customize algorithms somehow, so you need to keep some parameters, and how we usually, convenient way to keep it. So use some YAML config file, right? So just keep, and you can see here, so we have a list of processor. So you see processors, and then define class of this processor, and then just some parameters how to use it. And this is how we find it useful to reuse some processors. And once we define it, so we can just simple run with one line Python main specifying config, and that's it. So it works. Hopefully, it processes our data set. By the way, if you have any questions, comments, please do not hesitate to interrupt me. I think this way it will be more vivid and live. Yes. Okay. So I'm not going to talk about some deep mathematics or somehow something else. I don't like this slide, but sorry for that. So too many letters. Because we have a pipeline, so let me follow a little bit one by one what we did. So we have several data. So we have a speech in one language and captions, meaning like corresponding text in another language. And in this part of work, we don't interested in this. And we want only take speech in English and captions in English. So this is why we apply some language identification processor, which applies some model. Apply to audio, we identify language. Apply to text, we identify language, and then we match it. So once it's matched, okay, we can use it. So this is clear. So next, so generate pseudo labels using open source speech models. Okay, again, if we have some captions, we need to be sure that it is good enough to apply to further processing, right? So how we can be, like how we can understand it, we can take ASR model, like speech recognition model, and compare like predictions from speech recognition and captions which we found, right? And if it is not matched enough, so with some threshold, that is fine, okay. But to match it with speech recognition system, we need to standardize symbols, meaning we need to do some work, some cleaning work, exclude some annotations like music, noise, and typical kind of stuff. What else? So we need to do text normalization, because usually people in like captions use numbers. What else? Use I don't know, currencies and like dollar, euro, and so on. And usually ASR model cannot produce it, right? So you need to normalize it first and then apply it. So this is what implemented in this pipeline. And by the way, we did it, so we have some special, it is basically big problem to do text normalization. And we have separate project for this called NEMO text processing. So by the way, so our colleagues from Russian Armenian University already implemented text normalization in Armenian language. So you can like use not only big languages which is supported and already, yeah, thanks for them. It's kind of community contribution to this open project. So Armenian text processing, meaning text normalization, is supported by this framework. What else? Removal of non-alphabetic characters with text normalization. Sorry, I think it is too technical part. Conversion of text lowercase and removal punctuation of both. Okay. So this is basically like all we need to do text normalization and compare with ground truth our predictions and filter out. And final maybe stage to split our test set and trains out of train set. We did it by splitting whole YouTube out. Sorry, it's not YouTube. So whole video. So to be sure that the same speaker. Well, we cannot sure that the same speaker is the same speaker can be in different audio, but at least we split audio from like long audio in train from long audio in test set. So this is our pipeline, and what we had after it. We have a long list of languages, and here I show you only like top 4 languages. It is, you see English, German, Poland, and French. I don't know why. And train, def, and test set. So maybe because of like characteristic of German languages, they have its the utterance of German language is longer than in other, and the smallest utterance in English. Again, like interesting. I don't know why, and so we have this kind of set, and now we need to understand how it works with speech recognition. So, by the way, any questions so far?
So, you told that you use open source models for pseudo-labeling, but do you encounter problems with low resource languages? For example, for Armenian, I guess there is no good pseudo-labeler, let's say.
Yeah, good question. And so we work in Armenia about 2 years, and we already developed some quite good Armenian language and open source it, so you can find it on GitHub Hugging Face repository. So at least I know 2 of them.
So you use only one model, or you use several models and then see how well are the predictions aligned between the models?
Yeah, in this work, so I use only 4 languages, and for each of language I use one model.
Only one.
Yeah, but because it is like
languages here are common, that's why maybe the model is like providing good pseudo labels.
Yes.
What about low resource ones?
So it is a tough question, so you need to handle it somehow by yourself. Yeah. But anyway, I think you can use a multilingual model like Whisper.
Okay, but usually the problem with them, again, for low resource languages,
it's not so good, right? That's true. Yeah.
On the previous slide, you mentioned that you keep only samples having 75% of order rate or less. So one question, if, for example, I have a sentence having 4 words and another one having 14 words. For sentence, for example, if 3 words are different, it will show about 75% accuracy, but will you keep that sample also? Because it is about meaningless sample.
Yeah, it's true. Yeah, so this is word error rate, works as a percentage of, out of ground truth number of words. Yeah, if you take shorter, then it's, but yeah, maybe we can find
something relative. Word error, I think word error rate something relative meaning.
Absolutely, yes.
To take into account the length also.
Yes, sure, yeah, and it can be improved, so it is open source, so you can use another metrics. Yeah.
And how did you calculate the number 75? Why not 80 or 50?
Yeah, also good question. So it is like our internal feelings that it is good threshold. We're not sure about it.
And another question. The Armenian text normalizer, is it open sourced?
Yes.
RAW has.
Yes.
Okay. Good. Thank you.
Yeah, please.
Why we need to normalize numbers to letters?
Because usually speech recognition systems produce letters, and in order to compare like ground truths with predictions, you need to like have the same in ground truths and predictions. So that is why just convert numbers to letters, or in like whisper case, they can produce numbers, then you're fine, so you can compare numbers with numbers. Okay?
Means it depends on model?
Yes, absolutely. But usually, as I said, usually it's like easy for model to produce letters by letters, because letters is kind of close to phonemes, and like acoustic models usually produce like kind of phonemes. I mean, it's easy to produce phonemes.
Also, one more question. If I have English language audio and I want to have captions in Armenian language, I need to transcribe in English and then translate, or train the model with English audio and Armenian caption.
So you have audio in English and captions in Armenian.
I want my model to return captions in Armenian.
So if you want to, here we use only audio which has captions in the same language. So it's how to like match in the different languages. It's like another difficult task, and so it is out of this scope of this work. Yeah, but yeah, I think it is most informative part of this, because this is whole pipeline which we did, and now just this statistics of what we did and how we measure quality of this data set. So we take some models which we previously trained, and I put, so we use fast conformer. It is in that time, so we started this work about half of a year ago, and so I put leaderboard of different ASR systems in Hugging Face, and you can find that leaderboard like many models from Nvidia, then like Whisper, and then Nvidia, and then so a mixture of Nvidia models and Whisper, and fast conformer is like fast model. So, so you can see it's by RTFX value, and fast conformer is here. But so now you can see quite fast model Parakit, but it is new model. It just appeared. So we use previous model fast conformer, not Parakit. For this evaluation, and and also we don't want to like create the best model. We just need to evaluate if this pipeline works, if this data set helpful for ASR system. Okay, so we use fast conformer. It is fully converged previously, and then we take the same data set and add this part of new data sets from Common Crow, and train it until converge. So for these languages, it was like 2K steps. So for English, a little bit longer because it's like larger data set. And so we use these parameters. And evaluate on several benchmarks like Mozilla Common Voice, MLS, Multilingual, Libre Speech, Vox Populi, and this is our part. So this is, we trained with punctuation capitalization, meaning PC here. So this is with PC, and this is without punctuation capitalization.
The last two are yours, sorry.
Sorry?
The last two are yours?
Yes. I mean, our test sets, right? So you can see that's most improvement in domain. So out of domain, we still have improvement, but not so good. But we do have improvement. So meaning it's it helps to improve quality. Okay. And the most biggest, I would say, improvement in Polish data set, maybe because they don't have too large data set for training, and this is significant contribution to the in terms of size of data sets, and it helps a lot to Polish language. Yeah. So this is single language, right? So it's so this model predicts only one language. Okay. What else? We have several languages, and then we can apply it to multilingual model. And we do have in Nvidia multilingual model. It is called Parakeet. Oh, sorry, it is called Canary. And it is basically like encoder-decoder model, which take quite the same encoder as fast conformer, but a little bit larger, like 24 layers. And additional to encoder, we add 24 layers to decoder, and this model can do not only speech recognition, it is multitask, it can do speech translation as well. And this is a kind of leaderboard of multilingual models, and this is a word error rate, meaning less is better. So for these particular languages, like Canary is kind of the best, even with 1B parameters. This is why we try our data set on this model. So this model works with English, Spanish, French, and German. And as I show you, we have another 4 languages. We have Polish, but don't have. What don't we have? German we have, French, English, Spanish. We don't have Spanish, right? And this is why, so we evaluated it on ISR task for 3 languages. So again, it helps to improve ASR. And you can ask, this is multitask model, and it's capable to translate. And how about translation? Is it improved translation? The answer is no. So the translation is not improved, but and did not degrade at the same time. Okay. So Polish is not supported by Canary model, so this is why there is no evaluation for Polish in this setup. But it would be interesting in terms of previous slide where we saw best improvement in Polish. But anyway, this is how it is. Any questions?
Sorry for it, but I'm not familiar with audio domain. And I try to understand, you return to the slide the statistical data sets that you wrote. So know-how grow is big data of internet, and I try to understand why this number is too small, because as I can imagine, maybe in the whole internet we have a lot of audio data, and I try to understand which data you take, or maybe could we extract audio data from YouTube or not, and how it's working in general.
So yeah, in general, thank you for the question. So in general, it works like so simple matching task, and we have link to video, usually video or audio, and we have link to captions. And if it has the same name and the same domain, so it sounds like it is the same, like it is connected at least. And as I said, then we apply language identification, and it is the same language and so on. Yeah, this
So
is-
this number is too small because you have strong filters, or
yeah, maybe we have too strong filters. Yeah,
it's like
and
3,000, yeah, or 4,000.
yeah, and don't forget we have long tail of languages, right? So it's just the top languages.
Thank you.
Yeah.
Can you go please to web comparison slide?
This one?
The next one. Yeah, here. Previous one. Yeah.
Single language. Yeah.
Okay. So when you calculate the verb, it's uncase calculation, or you take into account also punctuations and special words, uppercase, lowercase?
Yeah, and here we see we have this line. This is common crow test set without punctuation capitalization. So without capitalization meaning so we don't have capitalized letters, and remain lines with punctuation capitalization. Okay. So to conclude, so we made algorithms for multilingual speech data extraction and to handle web scale data. So we developed pipeline around common crow corpus to find multilingual speech and matched transcription for supervised speech training. So we open source pipeline with long list of features like text normalization, language identification, ASR, and so on. So we evaluate the quality of this data using single language and multilingual model, and release these links and data processing pipeline for other people to achieve this data set. Thank you for your attention.
Do we have more questions? So you mentioned about running this pipeline for Armenia as well, or it was a different pipeline? You mentioned about text normalization.
Yeah, so we have some part of for Armenians like text normalization, ASR we do have. Yeah, but we did not do this whole pipeline for Armenian.
I think I only know one website that more or less contains parallel Armenian audio and text. That's public radio. That they sometimes literally write down what the journalist is saying. All others do not have it. Like
Okay,
the major news agencies.
yeah, it is interesting to have a look at the license at least. So,
It's a public radio.
yeah,
Okay.
we have some questions here. Question.
For example, again for Armenian.
You can use microphone.
Again for Armenian, like when you created this ASR model, on what data it's evaluated, and like is it your internal data or there is some public data?
For Armenian?
For Armenian.
Well, it is also a very interesting topic. I think I will have some another talk about it. So we release several data sets, text data sets, audio books, what else? Crowdsource, like vocalized text, unlabeled data. So we have some effort to achieve enough amount of data, like open data for Armenian, and to be able to open source model.
Yes, thanks. And regarding on improvement of the model, like how do you see the next steps? Is it just like only gathering more and more data and then retraining on it, or there is some novel approaches that can utilize like the whole spoken language and then transfer it to Armenian?
Well, if you're asking only about Armenian part, it's always in general. Low resource. I see. So what you can do? So definitely you can play with architectures and don't take too big architecture to prevent overfitting, right? So you can extend data sets. So you can leverage pseudo-labeling, like take unlabeled data and do iteratively pseudo-labeling. And like many approach you can apply for this. Yeah.
So mostly on decreasing the data size.
No, I think recent nice approaches also helpful for this. But you need to be selective, I'm saying so, because usually new approach is a big approach. So I think for low resource you don't need big approach. Big approach, you need clever approach.
Cool. Let's thank the speaker again.